Hello, today I want to talk about 2D arrays. Here I have prepared a small project. Currently it is empty, but there's a new rectangle function. It is a helper function to create a rectangular object. So if I say new rect and specify parameters width 100, height 100, I will get a white square at the center of the screen. I have a modified render script which basically just uses orthographic projection with 0 at the center of the screen. Okay, you know one-dimensional arrays? In Lua, every array is a table. So something like local array 1, 2, 3, 4, 5, 10. That's an array of numbers. And how can we represent them? With a one-dimensional loop in Lua. For I from 1 to the length of array, let's create a set of rectangles. So each rectangle shall be, I don't know, 20 by 20, and x value will be array element I multiplied by spacing between elements, for instance 25. And here we go, 1, 2, 3, 4, 5, 10. That is one-dimensional array. If we are not going to use array, but just a series of numbers, say from 1 to 5, we can just use the calculation on the I variable, and we are getting just 5 rectangles. How do we make a two-dimensional array? Let's first start with visual representation. So let it be for x from 1 to 5, do. For y 1 to 5, do. And x would be x by 25, y by 25. Here we go. A two-dimensional array representation. And now let's show some labels for the rectangles. I have prepared a label game object and label factory. Now let's modify our new rect function into new asset function, and we're still going to have function that is called new rect. New rect function will call a new asset function, but it will specify the type of object we want to create, so that would be rect, and here we replace rect with params type. As you may guess, we can now add new label function and specify type label. But how to add text? We are using the label set text. That's all. Let's try it. So let's recalculate position. Px, py. Spacing is 25. And call new label with the same position, but with a text. The index I, which would be a new variable. And we need to change the color of the rect. To say dark blue. I forgot to rename to component. Now we have rectangles with numbers. Yeah, let's make them a little bit bigger. And let's center them on the screen. For that, we are going to use negative values in the for loop. So instead of from 1 to 5, we can calculate from -5 to 5. We are going to have more objects. Yeah. And the label buffer is full. Let's increase. Very nice. Okay, so as you can see, we have quite strange numbering. 1 is over here, and it goes up 1, 2, 3, 4, 5, 6, 7, and then to the right. So this is not exactly what we want. Usually in games we have the first element over here, second here, and so on. For that, we have to swap our inner loop and outer loop. So outer loop would be Y, and inner loop would be X. So as you can see, it's now much better. It's 1, 2, 3, 4, 5 from left to the right, but still the first element appears at the bottom. We need it at the top. For that, let's also make it a bit smaller. For that, we have to invert the y coordinate. So not from -4 to 4, we need to go from 4 to -4. And if we run it, nothing happens. You know why? Because in lore there's a third parameter to the for loop, which is the step. And when we count backwards, we have to specify -1. Here we go. So now it is correctly placed. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is over here. Let's put 10. Let's make 10 by 10 grid. And maybe make our project window a little bit larger. Yeah, the screen is larger. So to make it 10 by 10, we need to increase each coordinate by 1. So instead of 4, let's start with 5 for the y and end with 5 for the x. Now we are getting 10 by 10 grid. However, it is not at the center of the screen. If you remember, the center of the screen is coordinate 0, 0. Let's quickly create a rectangle indicating the center of the screen. And let's color it with the green, no, with the red color. Here is it at the center of 55 label. It should be over here. So let's shift our entire grid, and to do so we need to shift it by half. So instead of 5, we're going to have 4.5 to -4.5. The same for x value, from -4.5 to 4.5. Now, yeah, we are getting the grid at the center of the screen, from 1 to 90. Small mistake. So, as you can see, the index of a rectangle of a cell inside the grid is tightly connected with its x and y position. And we can actually replace our double for loop with only one loop for I from 1 to 100. Let's shift it, remove I variable. Now we need to calculate x and y position. The x value is going to be I mod width of the grid. Let's call it grid width. And y component is going to be mass floor I divided by grid width. If we do so, again we are getting not exact result as we want, but very similar, because as you can see it starts with not 1 but actually 0, but we don't have 0, we have 1. So we can either switch to from 0 to 99 and have it starting with the 0, or we can account for that shift over here. Now we're getting 1, 2, 3, 4, 5 and so on. And to shift it to the center of the grid, we need to subtract position by half of grid width and half of grid height. And multiply it by spacing, of course. Now we are getting the result, but again it is not at the center of the screen exactly, so it should be also offset by 0.5. Now it is at the center of the screen. And again, the y coordinate should be reversed. To do so, we will subtract our current position y from grid height. When we do so, we are getting this result. This looks better, but it's still not correct. We have to position it at the center of the screen. To do so, we actually need to subtract 0.5, and now it's positioned correctly. And let's simplify this equation. So grid height minus half of grid height would be just half of grid height minus y minus 0.5. Yeah, the same result, and the center is here. So this is how two-dimensional array construction looks like when you just have one set of numbers from 1 to 100. Of course, you can change grid width to say 5 by 10 and it's going down, or you can make it larger, say 15 by 10, and since we only have 100 elements, it will stop at the 100th element and will not continue further. Sometimes it is useful to code your grid in a single for loop. Sometimes it is more convenient to use double nested loops. And now let's look how can we represent a two-dimensional array in Lua. A straightforward approach would be to use nested tables. So say we want our array to be 10 by 10, we are going to create a table for X component. Over here, and inside the inner loop we can assign a value for array like so. Let it be, I don't know, X multiply by Y. And to work with such array we will need a nested loop. So in this example we are going to display the number inside the array. Array X and Y. It is working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and to 100, but it is symmetrical because it is a multiplication table that you know from school. So this form looks convenient, but actually I do not recommend using 2D arrays in such a way, because it is easier to make an error in your program. For instance, if you will try to access array from outside of bounds, say, let's comment this out. Say you want to display value at coordinates 5, 5. That will work. That will output 25. But what if you're going outside from the array? So instead of 5, it's going to be 5, 11. You're getting nil value because there's no such value, because we are having an array from 1 to 10. And that is for the Y component. Look what's happening if we swap places for this call. We are getting an error attempt to index a nil value, because array 11 is actually a nil value, like so. Using it with any number here will result in a runtime error. And the fact that you have to create a table for each X value is really inconvenient, in my opinion. It really creates a dysfunctional data structure. What I like to use instead of this notation is just plain array. But instead of accessing it in this way, we are going to have a small calculation in the index. That is X plus Y multiplied by the width of the array. Which is 10. In this form, we are accessing the array like so, and instead of X and Y, let's have the same 5, 5, so we're getting 25. And if we change X to 11, going outside of the array, we are getting 6, which is incorrect, but it is not an error. It's not a runtime error. So to correctly use our data structure, we need some wrapper around this function. Let's call it array get. So let's check the bounds first. Like so. Now when we are getting array get 11, 5, we are getting nothing, which is nil. Actually funny why not putting a return statement results in a different output in default console. So here we have nil and here we have nothing. That is funny. I didn't know that. If we put it here, yeah, we are getting nil. Yeah, that's interesting. So, returning to our grid, we can replace this with array get function. Which doesn't work, because we need to put less or equal to width here. So now we are getting what we want, from 1 to 100. Let's fix it back to the center of the screen. Yeah, it should be not 15 but 10, because we have 10 by 10 array. Yeah, and let's change to minus 0.5 and plus 0.5. Yeah, now it's the center again. So you have to play a little bit with the values to offset your grid, but it's not a problem really. Using this approach with a single table for two-dimensional array really helps with a more streamlined data structure for your arrays. You don't have to mess around with subtables, and from the code point of view it's much easier to work with. So you can also have functions like array set, which would assign a value. For instance, array set 5 by 5 value would be Lua. Here we go. It's over here. And now what's left to do is to wrap all this array get and set functions into a class. Let's say local function new array2d of width and height. Let's have data for the array, and now the other way around. Let's have array as a class, and inside array there is going to be data field along with width and height information. And now we need to copy these functions. Function array get, array set, xy, self width, self width, self width, self width, and instead of array it's going to be self data. Okay, so we are storing the actual data inside this field. The array variable is our object that we are returning to Lua, and it has two methods, get and set. So over here that would be new array2d 10 by 10, and we can set here xy, x multiplied by y. Array set, array get. We are converting to object access methods, and now we're getting the same result. And now it's packed inside this pretty interface of array get and set. And we can also iterate from x from 1 to array width, to y array height, and actually replace it here. Yeah, it's working. So if we change our array, for instance 12 by 8, we are still getting a correct output. In Lua, tables start with index 1, but in grid programming, in loops, it's often more convenient to start with 0 value. And we can do so perfectly fine. We can rework our array to support 0 indices. To do so, let's start with changing this filling loop. So x would be from 0 to array width -1, and y component would be from 0 to array height -1. And we need to change our calculations for cell values, so they would go to not 0 multiplied by 0 at the start of the loop, but actually 1 multiplied by 1. And we need to change the check of x range, so it should be from 0 is now allowed, but self width is now not allowed, so it should be less than self width. Okay, and now we can change this loop, and let's get rid of it. Start with 0 to array width -1 and array height -1. We don't need that. And if we run it like so, we still not getting the center result that we wish. To make it work, we need to change this to -1, get rid of this 0.5, and put -1 here and get rid of this 0.5. Now it is at the center, and as you can see, it looks much more coherent for both x and y values. We don't have here -0.5 and we don't have here +0.5. So now it's just width -1 and height -1. Looks much better. Let's change it to, I don't know, 8 by 5. We get in the correct result. Maybe 9 by 9. Again, correct result, staying at the center of the screen. And maybe 11 by 11. Yeah, correct. Lua now at the center of the screen. Nice. Here you go. I hope you enjoyed watching this small tutorial on working with 2D arrays in Lua and creating grids in Defold. Please subscribe to my channel and please support me on Patreon. Thank you to all my supporters. You're awesome. Goodbye.